Welcome everybody, good morning or good afternoon depending on the time zone. Welcome to today's webinar with the topic Save Time and Efforts with Holistic Approach to Integration Testing. My name is Stefan Schuck from Polarion Software and I will guide you through the presentation and give you a short introduction. A short note at the beginning, this webinar is also as some kind of introduction for our visit of the SPS IPC drives on November 26th to 28th in Nuremberg. If you want to meet us there, just make appointments now and just give us a call. So, who will give you the presentations today? As I said before, my name is Stefan Schuck from Polarion. The main part today will be held by Euros Embedded by Mr. Christian Kersten. Another part will be from Vector Software from Mr. Niroshan Rajadurai. You will get a little welcome. We already had that, and an introduction to Polarion Software. Then we will go on to a short introduction to Vector Software, and then we go to the main topic for today, a holistic approach to integration testing. Before we come to a short demo, you will see the data exchange between Polarion and VectorCast, and then we come to the more important part of the demo, where you will see some integration testing with Euros. So just a few words about Polarion for those of you who haven't seen it or haven't heard about us before. So basically we're a German company with a headquarter here in Stuttgart, but as you can see we are distributed worldwide. So some countries like United States or Japan and so on are also taken care of by colleagues of us, so we have some other departments there, and other areas are just handled by other consultants or partners of us. So what can we offer to you? Basically, we offer just one thing. This is Polarion ALM. This is a piece of software we can supply to you, and ALM stands for Application Lifecycle Management. So this is one solution for every need for the whole development process. For example, some parts of this Application Lifecycle Management process are requirements management, test management, change management, task management, so quite everything you need in a development process, from the initial idea, from the initial requirements to the final product, and everything required for that. And so based on that, based on the fact that we have a quite flexible solution, you can see here that we are at home in different industry, like automotive, like aerospace, medical, like defense, manufacturers, consumer products, and so on. So there's one solution which fits most of the needs. And that shall already be enough, and with that I hand over the presentation rights or the control rights to Niroshan from Vector Software.
Thank you. So very quickly, just a quick overview of Vector Software as well. So Vector Software, we're a company that builds embedded software testing products, so that's really the core focus of what we do as a company. We're a company that's been around now for about 24 years, primarily focused in building software test automation tools. The first project that our tools were used on was an avionics project for a DO 178B standard, and since then we've grown out of the aerospace industry into the automotive industry, medical devices industry, railway, and industrial automation. Our corporate headquarters is in Rhode Island, and then we have several offices around the world, and so our European headquarters is here in London, where I'm based, and then we have the office in Germany as well, just near Düsseldorf. So lots of reference customers. So in the aerospace industry, we have companies like Cassidian or EADS, BAE Systems, Honeywell, Rockwell Automation, and so on. So roughly, Honeywell and Rockwell are standardized on our tools. So all modern commercial airplanes either have Honeywell or Rockwell parts in there. So quite a big user base there. Automotive, again, several companies there. Companies like Valeo, Magna Powertrain, Visteon, and so on. And then medical devices again, so next time you visit the dentist, the x-ray machine the dentist is using would have been tested with our software. And then railway, Bombardier, as for example, for the signaling solutions, and then industrial automation as well. So typically the customers that we have some kind of safety or business critical application, have a process which specifies rigorous testing, so unit testing, integration testing, and doing this based on the requirements that they have. And then also have a requirement to automate the regression testing as well. So not just testing once, but repeating the testing as the code changes over time. And also have a requirement to prove code coverage, to realize what they're testing and what they're not testing in their software, so that they can make sure that products aren't leaving their facilities with critical software not being tested. So our solution, true embedded test automation, the easiest to use tool on the market. So very intuitive and easy for users to go in and configure and get things set up. Support for things like continuous integration and continuous test, and test for repeatability, and this is becoming more and more important as the complexity of software grows over time. Engineers and managers want to be able to make delta changes to their source code and very rapidly re-verify that the code hasn't broken the baseline or any of its dependencies. And so these are kind of problems that we solve very well with VectorCast. And then we work with the best-of-breed static analysis tools, full embedded software testing, so unit and integration testing, measuring code coverage analysis through the life cycle, so whether it's unit testing, integration testing, or system testing, automated regression testing, so repeating the testing that we're doing, testing on real targets and simulators, so running your test cases on the real embedded device that you're going to ship with, or running on instruction set simulators, and then full qualification material as well. So if you need to certify your system, then we have qualification documents that can be used with the FAA or with the FDA, and then also we're TÜV certified as well for ISO 26262 and IC 61508. So we have pre-certification where you can take the certificate and present it to the auditor as part of the certification of your system, and that proves that the tools that you're using are acceptable for use as well. And so you can see here the kind of work rate that typical users are able to achieve using VectorCast.
Okay, this is a little bit too advanced right now, so let's stay here. So before I hand over to Mr. Kersten, I just forgot, if you have any kind of questions to our products or to the presentation, just give us a remark in the chat or in the Q&A window. And the important thing here is please don't send the questions directly to the speaker. Please send it always to the all panelists group. Only if you do it in that way, every one of us can see it and can answer your questions. Okay, so, and with that, I hand over the presentation rights to Mr. Kersten from Euros.
Welcome to my part of the webinar. My name is Christian Kersten. I'm Quality Manager at Euros Embedded Systems GmbH, a German software development company. My topic is how you can save time and efforts with a holistic approach to integration testing. I will start with a short introduction of the Euros company, and then add to the basics of integration testing, how it is defined, what are differences to unit testing, and then we will get a pretty fast overall view how you can see integration testing connected to different activities or results of the whole application lifecycle. As Euros does it, we develop for embedded systems, and when we do integration testing, we also have to do integration testing on a target board because we do cross-development. So I will talk about this too, and then I will show you a demo example which we are going to present on the next fair too. This will just be a short excerpt of the demonstration, but in detail it will be, the board will represent engine control unit and will receive sensor data over CAN bus, and this is very deeply integrated test then of the application, the operating system and the target hardware. The Euros company has a lot of experience collected over the last 26 years in developing software for embedded systems. Our main product is a general purpose real-time operating system. We just call it Euros, and we have another real-time operating system. This one we target the automobile market. It is called Eurosmod, and the Euros Embedded Studio is a basic Eclipse for C++ development with special Euros plugins, and we call it the Euros Embedded Studio. Another major product of us is a debugging tool, which we will use later in the example too. This is a small excerpt of our customers list or partners list. Now we will start with the real topic. I would define an integration test as the verification of a combination of modules or components. So if you focus the picture here, you can see there are different modules. Module 3, for example, is a very low-level module. You would verify it, if you verify it alone, with a unit test. And if you have also module 2, you could simulate the communication to module 3 at first by stubbing it, which means you provide a mock-up function which only returns predefined values. Then you can test module 2 in a unit test, and if you put them together, then you can test them in combination, which is then the integration test. So you would there focus more on the interfaces, on the protocols, if you have certain system entities which communicate over protocol, or the functional interoperability, because usually you divide components according to their functionality, and if you put more things together and the whole thing gets more complex, it's also critical for timing or the capacity. We will see what I mean with this in 3 examples. These are examples which can happen to you if you develop software for real-time or real-time in combination with embedded systems. This could be errors which you can uncover by integration testing. For example, if you have different components, put them together, then it could be that they have to share resources or data. And you cannot uncover errors if you only test a module. But if you put them together in an integration test, you can see this could be, for example, interrupt which changes a variable while another process would still use it. Interrupts are also typical for embedded system real-time environments. You can also run out of memory if you put different components together. Timing is also critical. For example, here you have a CAN driver, you tested it in a unit test, you tested it on the target, everything works fine. You combine it with a ADC driver, and this ADC driver has a lot higher interrupt frequency with about 100 microseconds each, and this could make the CAN driver starve from the CPU, and you cannot handle CAN messages anymore. So this could also something integration testing is useful to uncover such errors. There are different ways how you can integrate your components or modules. They are called strategies. The first most popular, what I would say, is bottom up. If we go back to the picture before, then in bottom up you would start with the lowest level part of your system and test it at first, and then integrate it and build your system up from the bottom. The opposite of this is the top-down approach. This strategy starts with the most upper part of your system, like you would do it in a more agile development process, like extreme programming, where you want to provide a mock-up at first with very little functionality, and then you fill it downwards with more and more functionality, how you like it, more in the deep or in the breadth at first. The third of this list of the popular strategies is hardest first. Hardest first means here that you want to identify these test cases which are most risky for your project or for the later use, and you try to get them to accomplish them first to reduce the risk of a project failure. And Big Bang also often heard, but I do not really prefer it. It's like all in poker, where you put everything together and test it at once, or almost the whole system. Now, you've seen that these strategies are also again connected with the development process you have chosen, or which software you develop, if it's complex or less complex. There are a lot of other dependencies which can influence your integration testing and which are not bad to take into account. You can see here different components of your application lifecycle which may influence the integration testing. For example, the experience you have with different components. Sometimes you have already a pattern which you can use to put things together, sometimes not, and this could be more challenging, and this could also be a problem in the end of the project. You always have to keep in mind that integration testing is one of the last tests next to system and acceptance testing. And if you get there some problems, then it could be hard to accomplish the project in the targeted time. Procurement could also influence your integration testing. When do you get certain components? For example, if you use operating system, you can get the libraries, and as soon as you receive the libraries, you can start to integrate small tasks of your system directly on the target and try to work with the drivers instead of developing everything on the host PC, only on the host PC, and never test it on the target. Another important thing is project FMEA, or in combination with the product FMEA, where you identify the components which are most critical for your project and also later for the use, which are most critical for safety or security. These have also to be tested, usually in more detail. And all these cross connections and dependencies, like also change management. How do you do change management? Are you able to perform nightly builds when something has been changed? This is a question of the tools you use. Can you rely what your tools are doing, or do you have to qualify them yourself? This is everything influencing your integration testing, and it is not bad to see what you have when you make your test plans, then to decide which tests do you choose first, which approach do you choose. If we go back to the strategies just for a minute, then you can see here it's not always that you only use one of these strategies and exclusively. Usually you can also use a hybrid version, like bidirectional search. One team starts from the bottom, another team starts from the top. They try to meet somewhere in the middle. Each team has, for example, some high priority test cases which have been identified as hardest of this part. This could be an approach for your project, but it is always important that you see all these different dependencies and then decide which approach is the best for you. We chose to do target testing very early because the target is a product which is not made by us compared to the software we do and our libraries. So we are not really aware of, is it really working? Is everything really as required or as intended? And so we start to do target testing very early. Here are some errors listed which could be uncovered by target testing, but usually not when you are only testing on your host PC. You remember, in embedded systems development, you do cross development. You usually develop your software on a workstation PC, perform first tests, unit tests, sometimes also tests of the compiled binaries with a simulator, but somewhere you have to go to the target, and there can happen that you can detect errors which you did not detect when you tested on the host PC. Here, for example, your target architecture could have different data types than your workstation PC, or your compiler could have errors which are not uncovered by the simulator. Or another big point is that the target environment is very different to your workstation environment, with especially the performance or the size of memories, or that you have real peripherals and which can also have interrupt the processes, and this makes a real difference to testing on a workstation PC. But usually you need certain environment to do this. We chose for us our Euros debugger to do it, but it could be pretty handy, and as we also use VectorCast for testing and Polarion for our whole application lifecycle management, we made a combination and made use of the already existing combination between Polarion and VectorCast, and now it is possible for us that VectorCast can trigger the Eures debugger to download the binaries onto the target, run it on the target, and get back the results through the debugger to Vectorcast. And if you have also integration between Vectorcast and Polarion, you can actualize your test items in the Polarion environment. Yes, as the next point I would go to the demonstration, but as I use there Polarion and Vectorcast, it would be nice if Stefan or Niroshan would introduce their software a bit better so that I can do my part then.
Sure, thank you. Thank you to this point. And now we will have a short look about a short look at Polarion and Vector. So here we are already in Polarion. So this is what you get when you get a look at the solution. So first of all, you get a browser-based solution for all your application lifecycle management parts. As you can see here from the basic interface or from the current project starting page, you can see an overview about your requirement specifications, about release planning, risk management, development, testing, and so on. So really every part you need for developing your products. And basically the Polarion is divided into two ways of working. The first one is work item type based. So if we go here, you get an overview about, for example, here every requirement which is currently in the project. So you can just go here, have a look into your list, and see all the details about your current requirements. For example, here in the requirement ECT26, under normal operating conditions, the system is defined by the schema run. And you see some additional attributes, some kind of metadata here. For example, which project you are, who's the author, what type are we in. You can also set additional information like, okay, what kind of requirement do we have, functional or user, set a severity, select a responsible person, for example here, Stefan Schuck, select an estimate in hours or days and so on. So basically everything you need to plan or schedule or to specify your items. Items, as you can see here, must not always be a requirement. It can also be business cases, tasks, change request, or test cases. So you see here that you could also create some basic test cases directly in Polarion. But of course, if you want to connect it to a little bit more advanced, or if you want to use it in a more advanced scenario, if you combine it with hardware testing, for example, the better way would be, of course, to connect your requirements with test cases coming from Vectorcast. So basically, what we can do here is to just give you information about the second part here of the concept of Polarion, is that you can also handle your items not just in a simple list like here, like you are used to from Excel, for example, but you can also switch over to the document where these items are contained in. So now here we switch to a specification, for example, here for an insulin pump, or for example, if we switch to another specification which we prepared for the demo today. So this is here an example of a drive pilot systems requirement specification for some kind of autopilot. And here you can see that you can work really as you're used to from Word or from other tools, that you can just start your document, enter your chapters, insert some basic textual information here as describing content for your requirements. You can continue to just specify your requirements here. You can see everything which is a requirement in your document marked with a little icon and such a gray bar here on the left side. Here you can see everything which you have in your current specification. And for example, here if I go to my item VCT 104, or maybe a better example here, 131, we have an advanced example here for a requirement. We can say, okay, the severity now, let's say we just raise the severity directly from the document to plan it in a little bit more detail. And we can also say, okay, we want to approve it, for example, or we could approve it here, select a responsible here, for example, myself, and set a requirement type for a functional requirement. And we can just save it, and everything is dragged down in Polarion. You can continue your work with the relevant and updated information. I guess this shall already be enough here for a basic introduction before we hand over to Mr. Kersten. And now I want to switch over to Niroshan, who will show us the other part, who will show us the VectorCast and show how the integration between VectorCast and Polarion is working. So, Niroshan, you're welcome as a presenter.
So what I have here is the VectorCast unit test tool configured for running. And here I've got the gateway set up so that we can communicate with Polarion. So the first thing we can do is we can connect to the Polarion database and import these requirements across. So you can see here it's a pretty seamless integration for getting this done. And then the next thing we can do is we can take a look at the source code that we want to test, and we can start looking at what requirements we want to do. So if we have a look here, you can see here these are the requirements that you saw before. And so here, for example, we're going to take a look at these two requirements, which talk about the vehicle speed and also the braking distance and so on. So if we take a look at the source code here, you can see here in this particular function, get speed from distance, it has some logic here, and it basically has a little algorithm here that determines the braking distance or the minimum braking distance based on our velocity. So if we come in here, we can create a simple test case. So if we right click and say insert test case here, we can put the test case in, and you can see here basically the two parameters for the function are visible here inside VectorCast. So if we open up the tree here, we can navigate down to those test cases that we had, number Vect130 and Vect131, and the nice thing here is if you hover over, you can see the detailed description as well. So here, for example, I think if the distance is 2, if we have a look here, it says that speed should be 0 kilometers an hour. So we can say 0 here and execute this test case. And so what we can see here is we have some execution results inside VectorCast, which are broken up into a number of events. So here you can see the input values being passed in get speed from distance, and here you can see the resulting value from get speed of distance, and you can see that it matches the expected value. And so if we want to create another test case, we can just right click and say duplicate test case, and this time the requirement says if we're 8 meters away, the speed should be 10 kilometers an hour. So we can change this to 8 and make this to 10, or we can even say 10 plus or minus 5, for example. If we're working with floating points, we can say 10 plus or minus 5%. Anyway, for this example, we'll say we'll say 10 is the requirement. And we can execute this test case now, and we can see that this test case is passed as well. And if we tick the box here, we can even view the annotated source code coverage. So we can see here, for example, the different colors. So a black line of code is not an executable line of code. A green line of code is a line that has full coverage. An orange line is a line that has partial coverage, so only the true or the false path has been taken. And a red line of code is a line of code where we need to do some additional coverage. So just for the sake of an example here, we can duplicate this test case, and here we can say maybe for the next example where the speed distance is 10, the speed should be 10 kilometers an hour, or 20 kilometers an hour, so if we can say 10, we'll just put an errant value of 25 here and execute this just to show that this fails as well. So you can see here that's flagged up as a failure as well. What we can now do is we can actually start pushing this information back into the Polarion tool. So if we go back to our Integrated Tools tab and we go to our Export button, here we can push these results directly back into the Polarion tool. So we'll give this test ID a name. So we'll say live webinar, and we'll put the date today. So it's 2013-11, and it's the 12th. And we'll say Export, and this will actually push all of our results back into the Polarion tool. So that's been done there. So if we go back now and we open up a Polarion tool and we just refresh this here, we should see our test run that we've just completed. So you can see here, this is the test run that we've just completed, and if we click this, we can actually drill down into the details here, and we can see, so in this particular scenario, we've got 2 test cases that passed and 1 that failed. And if we click the one that failed, for example, we can actually drill down into the individual test case. And if we click that, we can then even drill further down and look at the details here, look how it was run. And we can even see then further down the requirements that are associated with it as well. So if you click the requirements, for example, you can see even directly in the requirements, you can see which test cases are associated with those requirements too. So that's kind of a nice round trip that we have between the two tools. So that was a very quick demonstration of VectorCast and Polarion working together. So I can hand control back now.
Okay, thank you, Niroshan. So now we can go to the second part of Mr. Kersten's presentation. So I will give you back the presentation rights to start the actual, the more practical demo part.
And I will show you now how we in Euros use the environment with Polarion, VectorCast, and our parts to perform almost fully automated integration testing. As you have seen, you can work with your environment, your requirements in Polarion. You have your documentation there. You then can define test cases in the VectorCast environment, pull down the connections to the requirements from Polarion so that you have a traceability after you have performed your tests. You can perform your tests then with Euros directly on the target, and you get the results back to VectorCast. And as you have the connections to the requirements, you can upload the test case results back to Polarion, and from there your application lifecycle could start again if you have, for example, detected a defect and you have then change to be done, a modification of the software or another part, document or something, and then you would modify a requirement or add a requirement, and the whole process could start again. And here it is important that your environment has the ability to do this automated, so that you need to do for design, for thinking, and so on, and that things which can be automated, that you are able to automate them. And this is, for example, regression testing. You just make a small change, but everything stays as it is, and you want to see if everything is still working together, so that your modification does not blow up the whole system. So this means, for example, what you would verify with integration regression testing. Yes, and in our example, we chose Fujitsu board with a Cortex M3 architecture microcontroller. This is a Fujitsu FM3, and this target shall demonstrate how a engine control unit would work. Usually in a car you have this CAN bus. I have seen it, that there have been some questions what this is. So this is a bus where you can have several clients in a car, and you have data frames, and each participant on this bus can choose the messages which are important for him, related to a certain message ID. And here we send messages from sensors and simulate the sensors with a notebook. I have this here on my desk, and I will show you. And this notebook simulates a speed sensor, and the speed sensor sends data over to the engine control unit, also with the number of rounds per minute, and then the engine control unit can combine this with other sensor data and process what new instructions are to be sent to the engine. So the sensor data is being input from the notebook, from simulated sensors, over an adapter to CAN bus, and the board works. And we need also to test for our testing, we need to be able to look into the board with what is happening on the board. And for this purpose, we have a debug connection, and VectorCast is also running on the notebook. We have the sources on the notebook of our target for our target application, and we link together the compiled sources with a test harness. And this test harness is responsible to put data into our application. So we have predefined values as input data, and we generate output data, and this output data will come back over the debug connection to our VectorCast environment, and we will see whether the results are as required or not. I can show you how this looks here on my desk. This is the target board. I have two connections, USB connection for debugging, and here you can see a peak USB to CAN adapter, and the empty slots here on this white wire are for other participants of a CAN network. So this is how it looks like on my desk, and we have also application, which is a graphical application to show us how the speed would be seen in a car by the driver. You will see it pop up when we perform the first test. Again, as I said before, we have a connection to Polarion. We have here our project requirements and connect them with our test, and can start the test run now. Execute. Now you may have seen on the on my slide that there are two different ways you can perform your test: in the RAM of the target or in the flash ROM. If you perform it on the flash ROM, you always have to erase it first and then to write your program to the target, and this takes some time. This is what you can see here. If you test in RAM, it will be a lot faster. In the end, almost final program can be too large so that you can execute it only in RAM, and then it might be necessary. But these are then tests which are usually at the end of a project. You can do unit tests with small functions, with almost like code snippets, very fast, very easy in RAM. Okay, this was the first test run. What we have tested here, this is the case that the sensor, the speed sensor, sends a certain amount of data, and the data is being actualized each 100 milliseconds. Now the second test case would be a special application of target testing. We reduced the cycle time to 25 milliseconds. Both test cases could be passed on your workstation PC because it is very fast. You can do the processing of the CAN data very easy, and you will not have problems if you reduced the time. But if you test on the target, remember that it is a totally different environment. You have less memory, you have only 700 megahertz instead of a few gigahertz. It is very different, and it could be that you cannot be able to produce all the data in a shorter cycle time, and you would not detect such errors if you tested only on a workstation PC. I can show you the second example where it is not working. This is, as you see, this takes a bit if you test in flash ROM, but usually you would maybe try to do your first simple tests in a simulator environment, then maybe on the RAM, and you can do RAM testing very fast with small parts of your software system, and then if your software system grows larger, you have more integration done, then you can do flash ROM. How we did these tests here is, now you see it is failed. How I did this test here is that I made a test script. This is just a batch file where you can enter a list of regression tests, and I made it with a toggle, so if I start the first test, it does, if it call it the first time, it performs the test case 1. If I call it the second time, it performs the test case 2. And you can, of course, do a lot more test cases in your regression test script, and also with a connection to Polarion. This is here my Polarion environment. You see I have here a concept, software specification, and test run, a short example. You can also connect your regression test script to Polarion, then you only have to press a button. Your regression tests will be performed, and by the connection which I have set before, you have also the traceability, and this traceability is very, very, very important if you think of a certification. And yeah, then it is a good help if it is done automatically, and you do not have to make it manually. So this is really then for me personally, it is important that I can concentrate on my other stuff. Yes. Okay. Then this would be my part of the demonstration. I hope you enjoyed it, and I'm pretty sure that Polarion will also provide you the slides if you are interested. Okay. Thank you very much.
Yeah, thank you very much, Mr. Kersten.
Thank you.
Yes, so I will get back the presentation rights just for the final part. So I think every one of you got a good impression about how such an example or how such a scenario can look in real life. So you've seen how the data exchange can work from Polarion to Vector to send the requirements to VectorCast and just send back some fitting test cases to Polarion. You have seen it in the live demo. You have seen it from Mr. Kersten's example. Now we have still some minutes left for open questions. I think we've got a lot of questions during the demo and answered during the demo. So if there's something left, you have now the chance to ask your questions now. I can just see there's one open thing now. I'm not sure if we have the whole time for this. There was a question about if we can explain how to connect doors to ALM or to Polarion. Basically, there are two questions. One is by using regif. So this is at the moment just a manual exchange of files from DOS to Polarion and the other way around. Another possibility would be to use web services by the company ArgoSense. They are building an adapter for synchronization, and in the near future we plan to create an own regif-based automatical exchange between the tools. Another question here: in which format test reports are generated? So for the Polarion part of the answer, test results are generated as some kind of wiki page. So wiki pages are used in Polarion to display all kinds of data or all kinds of information which comes from Polarion. So also test cases or test reports or test results are just part of wiki pages for reporting. Not sure how is it done in VectorCast. What formats do we have there?
Sorry, I had the mute on. In VectorCast, we have HTML reports that we can produce and text reports that we can produce for the artifacts that VectorCast produces. But then we also have a Python scripting interface into our database, so users can also write their own scripts to go and query our database and export those into other formats. If they would like to as well. So if they need to feed into some modeling risk program or into something like that, then it's quite easy to interrogate our database and get that information.
Okay, thank you. So another question here, I guess again for you, Niroshan, is it possible and how to integrate any existing external application, for example .NET, in this scenario? Or also to Mr. Kersten?
I'm sorry, I missed the last sentence there.
Is it possible and how to integrate any existing external application, for example .NET, in test scenario?
Sure. So any existing application, so VectorCast works with code that's written in C, C++, and Ada. And if someone has an existing application, we have a tool called VectorCast Cover. And this can be used to instrument your source code and measure code coverage from the existing testing you're doing currently with your application, and you can then actually take that code coverage information and put it into our unit test tool, and you can see what code is currently being tested using your existing test process and what code isn't being tested. and you can then make a risk-based approach and decide which particular lines of code which aren't currently being tested you want to build some additional scenarios for inside VectorCast. So that's kind of a common way that customers who have an existing application would use our tools to try and improve the quality.
Okay, another question here. Does VectorCast cover Java applications too?
For now, no. VectorCast doesn't cover Java applications, only C, C++, and Ada.
Okay, and another remark here for the question before about the external applications in the test scenario. The remark is, I think, more about using any application for visualization of model execution. So maybe also related to some kind of Simulink execution, I guess. Is that correct?
Sure. I mean, if someone is using a modeling tool like Rhapsody or Simulink or Artisan from Matego or something like that, there is the possibility to take the data that's being used for model-in-the-loop testing to automatically generate VectorCast test cases so that we can then use that to test the source code. So in general, what we say is that if the data that you have to prove the correctness of the software exists in some other environment, and that environment is parsable, then it's quite simple to take that data and put that into VectorCast to repeat the testing on the actual source code.
Okay, I think that was the correct answer for that question. So I don't see any more questions here. So let's go on to the final part here. So first, thank you very much, everyone of the presenters, of course, Mr. Kersten Niederschan, thank you very much for presenting today and joining us in the webinar. And of course, thank you to our many participants who watched the webinar today. If you have any further questions which you couldn't ask now or send to us now, here you can see our contact information. So our web page is here for more information about VectorCast, about Euros Embedded or Polarion. You can see the email addresses where you can contact us for further questions or next steps. There you can also see, or if you go to our web pages, you can also see other recorded webinars about other topics. If you're more interested about VectorCast or Polarion, you can find it there. And of course, some other information about the products of Vector, Euros, or Polarion. And another remark at the end, as I said in the beginning, we would enjoy meeting you at the SPS IPC Drives in Nuremberg, in Germany, on November 26th till 28th. There, Vector, Euros, and Polarion will be presenting, and we will be glad to welcome you at the booth. So, yeah, make your appointments now, and thank you again very much for participating in the webinar today. Have a good afternoon or have a good lunchtime. Thank you very much.